Hi. How's it going? I'm here to talk about Cryptocat, and the subject of this presentation was in fact to be mainly adopting accessibility and ease of use of encryption tools, and why the ease of use of an encryption tool is a subset of its security properties. Before I get into the presentation, my name is Nadim. I started working on Cryptocat 2 years ago. I'd like to thank the Open Internet Tools Project for supporting my work and allowing me to be here. It's very nice of them. I'm originally from Beirut, but I moved to Canada, Montreal, 4 years ago. Now, has anyone here used the internet yesterday? Great. So you probably saw this, the wonderful mosaic of great news. Twice on the front page of Hacker News simultaneously. Not to mention a lot of other stuff all over the internet regarding just how terribly broken Cryptocat is. And this was, in fact, the case 12 hours before I had to give this presentation. And so I come here under the presumption that if I were to continue with my regular presentation, I would be insulting the intelligence of everyone in this room. And I'm not about to do that. I'm about to discuss, I will discuss my original presentation, in part. However, I will also focus on the circumstances relating to the bug that happened recently in Cryptocat. I will discuss what Cryptocat is, of course, for people who are new to the project. And I want to talk about the bug itself and why it blew up the way it did. So Cryptocat, part of Cryptocat, Cryptocat is a chat app. It's an encrypted chat application, very much like Facebook chat. The point of the project is to make, what we're trying to do ultimately as our goal, is to make encrypted chat accessible to anyone who knows how to use Facebook chat. You know how to have encrypted conversations. And this is to attack the issue that largely encrypted chat has failed to be accessible to regular, mom and pop users. This is the ultimate point of the project. We're trying to make it simple by using platforms that are accessible and building an easy-to-use chat app on top of them so that people can talk to each other about whatever they want and do so accessibly while maintaining their privacy. If you are to believe the internet, I immediately after coming to this conference ran to the nearest reporter I could get a hold on and told them repeatedly that Cryptocat is meant for activists only, especially if you're in Syria and especially if your life is in danger. I, in fact, did not do that. This is not what Cryptocat is about. There's a lot of people that say that we market towards activists, and this is something that, while the media has done sometimes irresponsibly, not something that the project has ever done itself. But after this small introduction, let me get to the bug itself. Part of Cryptocat, the part that deals with group chat, because we offered the feature to have chat rooms as well as the feature to have private conversations. The feature to have private conversations one-on-one uses the OTR protocol. The feature to have group chat, since we did not find a reasonable or suitable, group chat protocol for our purposes, we ended up making the big mistake of rolling our own. And we've been suffering from that mistake, paying for the price for the past couple of years. Anyway, we used elliptic curve crypto, curve 25519, as the key exchange protocol, public key exchange protocol for our multi-party chat. And the issue was that due to a ridiculous typing, not typing as in typo, but typing as in programming language, mistake, or I personally made the mistake of underestimating or miscalculating the amount of bits of security that the public key, the multi-party keys had. So instead of something around the range of 120 bits of security, it seems that we had something around a range of 20 to 50 bits of security, which is a disaster. This disaster happened because I am not a cryptographer. I am a software developer. I have a background in security that is self-taught, but I also have a larger background in programming, which is also self-taught. The issue that we're facing right now, and there are multiple issues that this bug points to. First of all, is an issue that was pointed to me today, which is a very important issue, is that in the context of public key crypto, writing unit tests to verify the legitimacy or the security of a bunch of, base 64 or pure binary or whatever random string of bytes that results, well, a glass of champagne. An unfitting delight for the bullshit that I'm making people go through. Thank you. So, where was I before the champagne? Right. I was talking, yes. So public key, you can't really write a unit test to verify whether this random data, because you obtain public keys through generating random bits as your private key. There's really no test that can really verify whether this is what I really want or not. It just looks like base 64, or looks like hex, or looks whatever the encoding is in ultimately. This is a problem, and this is what results in terrible bugs like this in happening. Another problem is that there are simply too many moving parts in this sort of thing. And you end up, when you want to end up targeting the goal that Cryptocat is trying to target, you want to make encryption that accessible, and you're ultimately going to have to rely on experimental technology. You ultimately have to going to come up with stuff on your own. And sometimes I did not follow best practice. And this is what happens. But the thing is, when you're, as the keynote speaker Meredith pointed out in her talk today, sometimes the only way forward is to fall into these horrible, inexcusable mistakes, because really, when you're trying to attack something like the accessibility of cryptography so bluntly, it's hard not to do mistakes. But at the same time, in the project, we've made a lot of mistakes. I've made a lot of mistakes personally, since I do most of the development. And this was my mistake that I made. And this definitely puts the project, for those familiar with it, and for those not familiar with it, the rest of the presentation may mean more to you. But for those familiar with it, this questions the legitimacy of the project and questions my legitimacy as the leader of the project. For those kinds of bugs to not only crop up this once, but to crop up repeatedly. They crop up repeatedly in other projects too. Big projects also suffer from these kinds of bugs. But those projects have had a decade to legitimize themselves. Cryptocat has not had a decade to legitimize itself. Ever since Cryptocat has begun trying to legitimize itself, we have had these bugs every couple of months. And this is not okay. So there's a lot of talk about how Cryptocat doesn't acknowledge this, about how it markets itself as completely secure, especially to activists in Syria, which is bullshit. And I want to address this frankly today, since I have the very lucky opportunity of being able to have a microphone in front of me right after this nonsense resulted because of my own blunder. We need help. If you are a cryptographer, please come. We do have some funding sources. I will try my best to get you paid if that's what you're into, and that's fine. Otherwise, we need people to start looking more at this. I am not going to give up on this project. I pay a price for wearing a Cryptocat t-shirt and giving this talk today after making mistakes like this. And the price that I have to pay is simply to ensure that this kind of thing doesn't happen again through honest communication, through asking for peer review, and through just not fucking up as badly as we fucked up, or as I fucked up before. So actually, the person who pointed up the bug, his name is Steve Thomas. I just wanted to address my thanks to him. He's kind of verbose in his critique, which is a typical part of hacker culture, and I deserve it. So, with that aside, I just wanted to make that perfectly clear. Cryptocat is an experiment that is necessary. It is necessary to have something that radically tries to make cryptography accessible, because the failures of accessibility and ease of use of cryptography are critical, and they lead to disasters a lot of the time. And I'll get into this. So this is a necessary experiment that I will not be giving up on, ever. But at the same time, in order for me not to continue ruining people's lives, as I tend to, you should probably stop me. And either by hitting me in the head with a blunt object, which doesn't seem unreasonable at this point, or joining the project and contributing to it, and assessing our decisions and also helping us write and come to a multi-party OTR specification, which is the ultimate goal of what we're trying to do now, and have been trying to do for the past couple of months, but it's really hard. But I'll get to that. With that largely out of the way, we'll come back to it to the end of the talk because it's really important. Look at this. Can you get someone to use this computer? This is actually very similar to the first computer I ever had when I was very young. I assume the answer is yes. It looks friendly, and it seems simple and easy enough to get a toddler to use. How about this one, with the very intimidating looking old man in front of it? Which one would you be more, privy to using? Well, that's because you're a bunch of nerds and you know how to operate PGP. And to be honest, I am not surprised by this answer. But were I to ask this question to anyone other than the cabin and crew of the Chaos Computer Club, I would in fact receive a different answer. I'm pretty certain. I would in fact use this one too, to be honest. It looks kind of awesome. It has like a captain's steering wheel. I don't even. Okay. But the analogy I'm trying to make, as I'm sure you've realized, is that we can be optimistic currently about the research done for encryption tools, about the variety of encryption tools. There's, disk encryption, chat encryption, email encryption, and a lot of stuff in between. The availability is, lots of open source projects. But the accessibility is the problem. And if we want to win the crypto war, which has now become a very vague term, if we want to, address the issue that crypto parties have tried to address in a different way, although crypto parties are awesome, there needs to be an effort to bring cryptography to the masses. Because from my own personal experience, and this is something that you can't really change my mind on, look, people are not going to start using PGP as it is right now. We will, but people won't. And I'm sorry. If you think that people will start using PGP the way it is right now, you simply, you might be a very intelligent person, but you're stuck in this sort of worldview that really is limited in the way people understand technology, which is very different from how you, a hacker or a geek, understand this stuff. Cryptocat is not necessarily the answer, but we're trying to make a statement that this stuff needs to be more accessible. You can go ahead and write a very accessible interface for PGP, and it can be completely separate and a lot better than Cryptocat. And please feel welcome to do so, but at the same time, you have to realize that there are disasters happening not only because of crypto bugs or because of implementation bugs or because of, buffer overflows or that kind of stuff. There's disasters happening because even the people who need encryption tools, not the people who would use crypto, who I would recommend Cryptocat to, for example, regular conversations, stuff that is not critical. People who really need to use PGP don't use PGP. And I know this from personal experience, from seeing people themselves being caught in terrible situations, political situations. And again, disclaimer, this is not to say that Cryptocat would address their problems either. I'm talking about PGP here. Because encryption was not accessible. Because even if you go and if you go to the X part of the world that people are currently having political problems in, and you teach them how to use PGP, and you teach them how to use OTR, Pigeon OTR, although that's a lot easier for sure, and a great project, although LibPurple, the library used for Pigeon has a lot of bugs on its own. They will not use it because either the circumstances don't allow it, or the person they're trying to communicate to doesn't know how to use PGP, which is a lot of the time, or more basically, it's a pain in the ass, and no one can get bothered to I'm in the middle of something and I have to get in touch with someone right now, and they're on Skype, and I can just go on Skype and press the green call button, and I get boo, 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 that Skype ringtone, and you're there and you're talking with them. And you won't get anyone to give a fuck about whether it's being monitored or not, or whether it's insecure or not, because really that's not their priority right now, even though it should be, and even though they know it should be. But that's how people work. They don't work like you and me. Everyone works differently, and everyone has an approach to technology that is different, and we need to address that. Even if I have failed in addressing it, some of you must address it. So when Cryptocat started, it was, as I said, I want to make private chat more accessible. Let's be extreme than Facebook chat. I want it to be easier for people to communicate on a private chat platform than it is for them to communicate on Facebook chat, which is exemplary in how accessible it's made itself, simply because everyone you know has it. Everyone you know knows how to use it almost instinctively. I mean, I use it with relatives, uncles and aunts who are 3 times my age, and they have they figured out how to use the Pusheen new emoticon feature on their own, even before I did. And we need to achieve this level of accessibility. And how does it work? The model earlier on was that you go to a website, but man-in-the-middle attacks and so on. So that was a very bad decision, one of many very bad decisions. So we switched to a browser app that you download, install. It's a signed browser plugin, or extension actually is the more accurate word. It's available for Chrome, Safari, and Firefox. You download it, install it, and you get a screen available in 35 languages. And you enter the name of the chat room and your nickname, and that's it. And you're inside the chat room, and you can chat with people. It doesn't even show you that the encryption is happening. The interface is similar to just like a regular, fancy-looking, colorful, friendly chat app, and that's the point. Usability matters, and so the interface was made to be familiar, colorful, appealing, and actually we succeeded in that because I got some nice emails, for example, from, aside from the emails accusing me of killing people through my terrible crypto, I do get emails, for example, from preschool teachers who are like, hey, or middle school teachers, I forget actually which level. Hey, your app is really cute, the kids really like it, and we're using it to teach them about the importance of keeping your privacy online. And so this is a testament to how accessible the app is. It has audio and visual notifications that are appealing, aesthetically appealing, and more features like that. So we chose the web browser. I chose the web browser. I mean, partly it was because I was already familiar with JavaScript when I started, to be honest. But also, it was still a conscious decision in the sense that it's a very accessible medium. It's the most accessible medium, HTML5. And it was one of the most dangerous platforms, perhaps, well, no, not the most dangerous, one of the most dangerous platforms for cryptography engineering. The challenges were many when we started in 2011. They've gotten shorter, but they still remain huge in number, or almost insurmountable in number, or in severity, although they might be smaller in number. So, for example, random number generation in the browser is completely fucked up. It's not fucked up anymore, but when we started 2 years ago, it was. Browsers only had, as far as I can tell, one randomness function, which was called math.random, part of JavaScript. I'm sure you've heard of it, maybe if you're a programmer. And it relies on the date and time, except in Opera, which in fact is it's a cryptographically secure pseudorandom number generator in Opera for no reason. Math.random, I had no idea. But any other browser, it's just date and time, random numbers. As you know, if you want to generate private keys, yes. Diffie-Hellman private keys, elliptic curve private keys. This is not a good thing to do. You need to have more secure, more unpredictable random numbers. And so what we did was try to counter that problem sort of half-assedly. We'd ask the user to type on the keyboard, move the mouse randomly, and then you'd have entropy, but not really, not a very good answer because there's patterns that form when people type on the keyboard. I'm sure every time you type on the keyboard randomly, you're more likely to type as the than a Shakespearean poem. But luckily, a standard was formed called window.crypto.getRandomValues, and this is in fact, it calls, I believe, from NSSlib. For random functions, so it might drain your entropy sources if used improperly, and that's a problem, but at the same time, it made it so that this problem was solved. Perhaps not completely, certainly the definition of solved is dangerous to use, but that the problem was made less dangerous. Code delivery, as I mentioned earlier, there was a problem with the first version that we started a couple of years ago, which was just a website, and over SSL, we'd send you the code, and you'd run it on the client side, and you're done. You have like OTR on the client side or whatever. And that's bad because every time you'd open the website, you'd be downloading the app all over again, which opened a very wide breadth for man-in-the-middle attacks. And the way we are trying to address this is by using signed browser extensions. So you download and install it only once locally. Of course, there's auto update, and if you really have security concerns in that sense, you can just disable auto update. But in that sense, it was made to be just like a downloadable app, like any Pigeon or World of Warcraft, whatever. So that's not perfect by itself, but the thing is, it's kind of optimistic in a couple of ways. If you look at, for example, Chrome OS, which was, by the way, contrary to what I thought, in fact, it was exploited during the Pwn to Own contest, but it was the hardest thing to exploit, if I'm not mistaken. I think I'm not mistaken. Chrome OS and Chromium, the Chromium project in general, is really achieving an impressive level of security that we can look up to for the browser. It's better than a lot of stuff. And it has good sandboxing, it has certificate pinning, you have Adam Langley handling their SSL, so obviously it's incredible. And there's, aside from that, aside from the problem of code delivery, there's cryptographic implementations. So how do you trust? There's a lot of standardized libraries right now, but really, for AES, for SHA, for cryptographic suites, but they haven't gotten a lot of review. Even Dan Bonet's team of undergraduates, I believe, wrote a Stanford JavaScript library, which is in fact, I think, being used as one of the bases for what's happening right now, which is in fact a peer-reviewed standard for cryptographic implementations in the browser accessible via JavaScript, called, it's being formulated by the W3C as a standard, which is incredible. The W3C Web Crypto Working Group, and it's going to be just a bunch of native implementations in the browser for AES and SHA-256 and everything in between. And this, I believe, would help addressing the cryptographic implementations problem. Although there are still surrounding issues, perhaps they will fail to address timing attacks. Perhaps implementations issues will remain, and so on. So this doesn't really solve the problem entirely, or I don't think it would. So ultimately, is it worth it? Is it worth it in the context of the terrible, heinous mistakes that we have made along the run, trying to make cryptography more accessible? Certainly, there would be those mistakes. We have had every single kind of mistake. We tried to make it really accessible by just making it serve off a website, and there was a man-in-the-middle vulnerability, and that was a big mistake, an unforgivable mistake that I take full responsibility for. There was UI mistakes, like I messed up the way that nicknames were shown in the buddy list, and you can just inject code that way and like compromise someone's private keys. So when you're designing a user interface, there's problems from that end too. There's a lot of we once overused used repeatedly CTR, ASCTR counters. So there was a decryption that was possible there. This was, I think, last year. And there's now the erroneous, misleading level of entropy and security, number of bits of security that the elliptic curve keys had. These mistakes keep popping up, I think on average like once every 4 or 5 months we have like one of those mistakes. We've had four or five over the 4 or 5 like huge mistakes over the lifetime of the project. And it's really like at one point you have to wisen up and ask yourself, is it really worth it? Is it really worth it to say, hey, we're making cryptography accessible, but it breaks and ruins your confidentiality on the clock once every 4 or 5 months and destroys all promise, any possible promise or vestige of privacy or confidentiality it might have ever instilled in you? The answer to that question is subjective and difficult, and I personally am not sure that the answer is yes. There are some improvements. I have a team of volunteers that work very hard on it. I myself have dedicated a lot of time to the project. We implemented OTR thanks to the incredible work of Arlo Bro, a fellow Canadian who lives in Canada somewhere. I don't know if I should tell you where he lives, but so we implemented OTR in the browser for the first time ever over XMPP in the browser, and we can serve this as a browser extension. And this is a real usability win. There's no guarantee that the implementation is secure. It needs a lot of auditing. We've done our best to verify whether it's secure or not, but as you can see, we're quite fallible. So we wrote a specification for encrypted file sharing over OTR, and that's been looked over a couple of times too, and it still needs more looking over. But it's still something. These are still achievements. These are still achievements that break often and result in disasters, but they have in fact resulted in research being done in making these things accessible in fact, the most accessible medium and one of the worst, the most toxic mediums for security and privacy and cryptography engineering or cryptography implementation. I wrote this slide, you know, this slide is not accurate. The answer is not really yes. It's not no either, but I think it's more no than yes. We have, in fact, made private conversations that destroy your confidentiality and fuck you over every 4 months accessible to teachers, LGBTQ couples, counselors, journalists, friends and family, and business people, you know, just a laundry list of random people who send emails saying, hey, I found Cryptocat useful. I don't keep track of who uses it, obviously, but that's how I can know, because they send thank you emails. People have, so we know for sure, even if we don't know whether this kind of accessibility is possible without fucking up, we know that it needs to be done, because we know that we're reaching a bunch of people right now that benefit from it. And so if I don't have the skills for it, you certainly might want to consider writing, you know, a trans-platform mono app, you know, just saying whatever comes to mind, you know, definitely good advice, but you know, a trans-platform mono app that also works on phones, that lets you, you know, that's completely open source and peer-reviewed and does a lot of stuff to be accessible. For example, translations and usability features and interface and aesthetics. That can also work. Because accessibility can increment towards security. You can start with something really accessible, and you can increment towards security progressively. So what you should not do is start with something really accessible, make it so that tens of thousands of people around the world are using it, and then increment towards security. And that's the mistake I inadvertently and unintentionally made, because then you end up screwing over those people with their trust on a regular basis. And this is not something that should happen. But you still solve very, very serious problems in accessibility, which I no matter what you say, Thomas Ptatek, I stand by my words. Accessibility is really important. And you know, Thomas Ptatek is a very well-respected guy who has a lot of smart things to say, and that's why I wanted to mention him. He has a lot of good comments. Hello. So when you are addressing this problem, it's definitely the case that there will be pitfalls. And it is definitely the case that this will happen, as is the standard procedure of open source hacking, of open source security. Localization matters. This is just a slide to remind me that we did, in fact, have over 35 languages covered. And this is another aspect of accessibility that people should be aware of when designing privacy-enabling applications that are meant to be accessible. That you can, in fact, break a lot of societal, cultural, and linguistic barriers simply by making sure your app is translated into languages and dialects around the world. There's a lot of future work to be done. I'm very dismayed that Rainey Reitman missed my incredible series of very long apologies about how Cryptocat sucks, because I really was looking forward to her hearing them. Perhaps later. But look, the current protocol that we use for multi-party chat, we use OTR for private chat. OTR is fine, apparently. We use our own home roll, terrible, cancerous, pyrrhic, Mordor-like multi-party protocol. I'm making it funny here, but it's not. And the thing is, we do this because there is an accessibility failure. We do this because there really isn't, or hasn't been, as far as I know, a way to just roll a pre-existing standardized protocol of multi-party group chat and package it into something accessible. Sure, maybe you can use PGP, and that's something I should look into. But a better way to look at it would be to expand the pre-existing OTR standard, which has already made strides in making cryptography accessible. Pigeon OTR has made a serious effort to making crypto more accessible, although that's not where the buck ends, obviously. So if you are interested, if you are a cryptographer, if you are an engineer, if you're an auditor, if you're, you like cats, I don't know, please, we're working on getting people interested in formulating a specification for MP-OTR. Dr. Ian Goldberg, the guy who wrote OTR, is not really that involved anymore. He doesn't have a lot of time with other responsibilities, but he did write a paper vaguely, abstractly defining MP-OTR. It's not enough to implement it. I can look at it, but I'm a programmer first and only culturally educated in security second. We need people with PhDs in cryptography to look at this. And so we can implement them, and so we can have another team of people to review them. FX. And so that's very important. That's the most important thing. Other cool but less important things are investigating whether WebRTC, which has built-in DTLS/SRTP encryption, which apparently we're not sure whether it's good or not, thank you, is safe. And if it is, we can use it for implementing web and audio chat in a way that's accessible, which also was brought up to me by a gentleman here today. I don't know where he is. Better authentication, SMP, the Socialist Millionaire Protocol, which is already available in Adium OTR and Pigeon OTR, is a really good way to make authentication accessible. Ironically, it doesn't exist in Cryptocat yet, although the pull request is there, and the guy who made the pull request is very angry at me for not getting to it yet. And usage metrics that maintain anonymity, that's not really important. And your own features are you to suggest them. You can get involved. We're having a hackathon in New York City, organized by OpenITP, the gracious organization that supports open internet tools development and supports my work. It's in New York City. You're free to come. It's obviously free, and we would certainly support you being there to work on the things that I mentioned. There's a list of website, Twitter, IRC, my own personal email. I only left 15 minutes for questions, although I would have liked to leave more, because this is a good time to answer questions. And please feel free to be as critical as possible, although please be not like people on the internet.
I just would like to add that every chat you encrypt correctly, you're better than Skype.
Oh,
well, with every single communication you encrypt correctly, you have been better than Skype already. Because,
Meredith, just one moment so I can comment on that. So look, my metric for evaluating whether Cryptocat is a good thing to use for people or not, I've only used one very simple metric ever. Is your alternative only Facebook chat? That's it, or Skype. And if they say yes, and it's not an extraordinary situation, then I would say, yeah, use Cryptocat. Because really, some people disagree with me. Some people think Facebook chat is actually better than Cryptocat because Facebook has the organizational legal backing to protect itself from legal requests, whereas Cryptocat doesn't. This is in fact an argument, by the way. Yeah, there's something called Prism. Okay, the guy who made that argument and I don't get along very well. But but personally, this is the metric that I use. Meredith, please.
All right. So just taking as a given that you're owning all of the responsibility for the flaw that happened. My understanding of this, and correct me if I'm wrong, but my understanding is that the bug was fundamentally the result of binary data being interpreted as something else, like as integers.
It was in fact a typing mistake in the programming, yes.
Right. So my question here is, and I know you mentioned that the browser is pretty much the most hostile environment.
One of the most, yes.
Yeah, that you can implement security protocols in. How much of that has to do with the fact that JavaScript is just a shitty fucking language for dealing with binary data?
It is in fact a shitty language. There's a lot of very funny stuff if you try to do bitwise XOR or.
Right.
No, sorry, bitwise XOR is fine.
For reference, I implemented SHA-1 in XSLT one time. Don't ever do that.
Yes. I imagine I would never
Don't
do
try
that.
to implement cryptographic hash functions in languages with no
Okay,
bitwise
so,
operators. It does not end well.
JavaScript is a very interesting language. Look, look, on my Twitter feed it says JavaScript advocate, and I'm a JavaScript advocate because of the look, it's unprecedented ever in the history of whatever. We haven't had something that's as accessible to people, but also like as accessible to both the programmer and the end user, and as multi-platform. This has never happened before, at least from my limited perspective. But absolutely, I mean, try to implement, just like test exercise, try to implement MD5 in JavaScript, which is something that I did. It's just not made for that stuff. It's not. It's like the Lego blocks are too big, and the hole you're trying to fit the Lego blocks into just is too small, and it's just like your fingers are too fat. That's what it feels like. And this is, in fact, yes, a problem. I mean, I don't know if it can be addressed with future modifications to the specification, or perhaps the better way to address it would be to do what the W3C Web Crypto Group is doing and implementing native implementations of things that are difficult and rely on more low-level code.
So I've just put on my programming language theorist hat.
I see.
And so my question there, as a programming language theorist, we've been talking about how do we improve the browser environment, because that's really what you've been pushing to do. How do we make the browser environment a better environment for developing safe software? But everybody always comes at me for being a bondage and discipline language fangirl every time I bring up Haskell. Where's the middle ground? Where do you see the middle ground being with your experience?
There has to be improvements. Look, I think the stuff that Chrome is doing is really interesting as a pragmatic level of looking at this sort of thing, because like I have so much respect for Adam Langley and the people at the Chrome team. They take really pragmatic steps to addressing problems that can't really be addressed very quickly, but they take steps to mitigate on the short term, and then hopefully we can formulate something on the long term. For example, SSL certificates. There's certificate pinning in Chrome, which kind of helps, but really the problem is still there. There's a lot of, Chrome was, I believe, the first, I may be mistaken, the first browser to implement sandboxing. These are features that affect the user positively in terms of performance as well as security. And I think those sort of engineering, very base engineering approaches are probably the best way to address this. If I, did I misunderstand your question? Or?
I guess I was more sort of asking, what would you do to JavaScript to make it better?
JavaScript. Oh, so I'm sorry, I must have misheard. What do I do to JavaScript to make it better? Short of, perhaps look, a lot of it has to do with education. A lot of it has to do with implementing and standardizing better coding standards, better coding practices for JavaScript, which is really the main reason it's evolved, along with having the support of Google and the V8 parsing engine, why it's evolved to be a usable language more and more today. But also, I think on a level, you just have to start addressing the specification, the ECMA script specification. And this is something that's way beyond my capacity to answer. I really, this is where my proficiency ends, unfortunately. Or perhaps fortunately, if it's the ECMA script specification. But please, any more questions? Yes?
Just to finish this language question off, what do you think of perceiving JavaScript as like the WebAssembler? AKA, unless you're mentally retarded like I am, you shouldn't actually write this stuff. You should compile to it. Like, use a decent language and compile to JavaScript.
There are some options to compile to Java. So the question is, do you want to use just JavaScript, or do you want to, perhaps it would be better to use a decent language that compiles to JavaScript? There's a lot of recent stuff to compile to JavaScript. There's, more hipster stuff like CoffeeScript. And there's more interesting stuff like asm.js, which really just really improves the performance of JavaScript, but also lets you program in other languages and compile to JavaScript. And the problem with that is that, okay, so from my limited perspective on this, I can see two problems. The first problem is that sometimes JavaScript is not to blame. So this ECC thing, obviously it was a typing error, not typing as in typo. Typing in a more programmatic sense, but this error happens, it's not entirely to blame on JavaScript, it's simply like a human mistake, 90% or heck 60% of it. But the other part of it is that those transformations from X language into JavaScript might not necessarily be secure themselves. Somewhere along the parser or the interpreter, you might have I think it's a nice place to use a system call here. It's like to optimize. Or I mean, this is really not a realistic example, but you get what I'm saying. So yes. No one wants to throw a pie at me, really? Bullet to the head? Come on.
Pretty much to wrap up again the language discussion, because it evolved into a wonderful, wonderful idea. How about using industry established or community established solutions, such as, for instance, this PGP, and actually using PGP through the existing models of say Scripton, which is a backend for LLVM, allowing you to compile arbitrary C code into effectively JavaScript backend. Yes. By doing so, you would have, on one hand, the benefit of well-tested and well-established source base. On the other hand, you have the ability to tap into these wonderful install base of JavaScript.
So the question revolved around the use of things like Scripton, which I forgot to mention. Thank you for reminding me. Which is an interpreter that parses C into JavaScript, which is insane and awesome. But again, might be sort of like vulnerable to the sort of bugs that appear upon the conversion, which I'm not particularly professional or learned upon. But why not use that to implement pre-existing standards like PGP? So this is definitely possible. And the thing is, PGP is already implemented. Perhaps it's wise to do it this way too, but it's already implemented natively in JavaScript with openpgp.js, which is a project that does that. Oh, okay. Are you guys behind openpgp.js?
No, they just use the
one. Oh, openpgp.js.
Yes.
Oh, cool. Initially. Initially, before we found the ODE.
We actually did GPG for browsers, which implemented a GPG interface for use in Gmail on Chrome.
I see.
Thank you. This is where the crypto.get random bytes function in the Chrome browser actually comes from. Values. Like the cryptographic secure random number generator that now made it into Firefox as well.
Yep.
Yeah. Instead of writing cool code, we actually pushed on the two vendors to implement that.
It was you.
Yeah. Sorry.
You were bugging David Dahl too. Awesome. Great.
Yeah, and then because there was a bunch of other people that wanted a portable and appable PGP library, we made it open source and essentially used our code base to jumpstart Open PGP.js.
Thank you very much for that. Seriously, this is really invaluable. A very invaluable contribution. Aside from that, also a really cool volunteer called Arlo Bro implemented OTR in the browser in JavaScript. So, and his implementation, from what I've seen, is really cool, really, really well written. It has even nice features like SMP, for example. Yes.
I have the...
Sure.
First things first, you were wondering why nobody's throwing pie at you. I think you've done a great job to explain what's going on and where the issues are. So
have you seen Twitter?
Who cares about Twitter? I mean, seriously. No, I mean... I think you deserve a round of applause because I think you've done a great job to explain what was going on and what went
This is like
wrong.
A disconnect. Like, do you guys turn into werewolves when you go at home and just like, Wah!
I think the people in this room actually understand how hard the
project is. And the question that I wanted to ask you is, I agree that accessibility is a big issue with crypto because we have many great crypto implementations, but they're really hard to use, and that is a big deal. You try to do it for chat, to make it simpler for chat. Where do you see the next construction sites where we need to do a better job?
How about an embedded, how about a mail client whose only purpose is to embed PGP into it and call it crypto mail cat or crypto mail duck, crypto mail puppy, I don't know, whatever. And
Crypto BIF for historic reasons.
Crypto BIF. Okay. I am too young to know these reasons. But anyway, look, the model of Cryptocat can be followed outside of the browser if necessary. And it doesn't have to be limited to my own personal biases to what I believe is accessible. It's just, the issue is, the model that I've used is make an app that does one thing. For example, make an app that's a desktop app that's available Mac, Linux, Windows, that does one thing, such as offer a channel for PGP communication via email, and only that thing. Make sure the aesthetics of the interface are accessible and that they fit together into something that seems unified, which is, by the way, like, look at Linux, look at Android, look at GNOME, look at KDE, like the failures in unification of interface and aesthetics is abhorrent. And so get over that, which is what Cryptocat tried to do, and I believe succeeded, one of the few things in which it succeeded in. And localize it, translate it, make people use it, make it attractive, make nice, graphics, because even those nice graphics become, in the right context, security features, because they encourage people to adopt these security practices. And you have to start doing that. It's not distractions, it's in fact a last resort. So that would be one way. Yes, please.
I just wanted to ask, since you are using the extension technology in the browser,
Yes.
What do you gain from that? I mean,
Okay.
I think you're still 100% JavaScript. Is that correct?
That's correct.
Okay, but what do you gain exactly?
So the question was, we're using browser extensions to deliver Cryptocat, right? Why is this good? Why are we doing this? What do we gain from it? It's still JavaScript. And so the answer to that, which I think I kind of touched upon in my talk, was before, we didn't do that always, and it was a big mistake. What we did was serve via SSL, HTTPS, from the website directly. And this was a problem because you would need to re-download Cryptocat every time you opened the website. And so this really opened a very big channel for man-in-the-middle attacks, or even, much worse. For example, this guy, I want to send him a backdoored version, but not to this guy. Say Cryptocat's delivery server is hacked into, right? You can make it so that everyone with a American IP address gets version A, and everyone with a Canadian IP address gets version B, right? And so and it gets worse and worse and worse because every single time you open the website, you're re-downloading again. There's no verification. There's no authentication of the binary that you're using, that you end up using. And so with signed plugins, the model starts resembling more the model of just regularly downloading an app like Pigeon or Team Fortress, like just any computer game or any application. And so that's why we switched to a browser app. And really, it's been a very, very much better choice, for sure. It helps with security, as I mentioned, but also with opening up browser APIs, and also with making sure that releases are more organized and that versioning is easier and more organized. Well, any more questions?
Sorry, I think we'll stop here now. So.
Very well. Well, thank you very much. And look, sorry, just one thing. I know this was entertaining and fun for all of us, but look, don't forget, this is really serious. And for this kind of accessibility project to continue, we do need your feedback. It's not working very well right now. We are making a lot of mistakes. We need a larger team of people, and we need to formulate policies that and practices that makes this stuff not happen anymore because it's not working as it is right now. And just one more time, would like to repeat. This is an experimental project. This was never meant for activists or anything of the sort, and I have never said this myself, although people keep insisting that I did. And this is just a project to make a point and to research into how to make cryptography accessible. A lot of people use it. A lot of people use it thinking it's something else. And this is my failing. This is actually my failing. But we need to work on communication and this sort of thing. And it's actually covered in the paper that we published recently, so it's available on the blog. Check it out.